This lesson is 11.4, talking about arithmetic series. You've already heard the word arithmetic before. Remember, that means that you're adding a common difference to your pattern. So you're adding a D. And remember that when we use the word sequence, we mean a pattern. So a sequence, for example, right here, is a pattern of numbers that's happening. A series, which is what we're learning about today, means that you're summing up all the terms in the sequence. So you're putting together all these numbers and you're putting little plus signs between them here. So that's what you see on this side, a plus sign between them. And so this will have some answer that it is worth. It'll be worth some number. Now, we also have the idea of finite, which you see here. So a finite sequence, finite pattern, and a finite series or a finite sum. We also have infinite sequence, which means that it goes on and on and on, it never ends. So an infinite series would be summing up all these terms, but it never ends. So as you think about what this would be worth, because you keep adding, and you never stop, an infinite arithmetic series is going to approach the largest number possible. It's going to approach infinity. So today we're going to be focusing on the finite section here. And how do you add up the terms in a sequence? So how do you find the series? So whenever I say series today, you need to think sum. What is the sum of all the terms? So write the related series for each finite sequence, then evaluate, that means find the value of each series. So first of all, here's our sequence. The series would be 1 plus 2 plus 3 plus 4 plus 5 plus 6. It's that simple. That is the series right there. So that's step one, check. Find the value of it. Means that we're going to add all of these up, and we can sit here and we can say 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and so on. So 10 plus 5 is 15, 15 plus 6 is 21. Remember, we found that pattern yesterday where you could add up the first and the last term and get a 7, and the 2 and the 5 are also worth 7, and the 3 and the 4 are also 7. So we could also say 7 times 3 pairs is 21. So that's what it is worth. Let's try our second one here. The sum, or the series, will be -2 plus -4 plus -6 plus -8 plus -10 plus -12. And we're going to go ahead and use that shortcut pattern. We're going to say -2 plus -12 is -14. And we have 3 pairs, because we have 6 numbers. So 3 times -14 gives us -42. So what we were just doing here, that's this formula, and we saw this in a previous lesson. We said where this is your first term and this is your last term, and this is the total numbers you have, so this is pairs. Notice that this only works for a finite and only for arithmetic sequences. We'll talk about geometric later. But it only works for finite because you have to know what the last term is. If it was infinite, you wouldn't know what the last term is worth, so you couldn't put it into your formula. All right, so a little more practice with this. These two down here, we're asked to evaluate or find the value of the series, the sum. We're told that they all have 8 terms. We're not told what all the terms are, but that's okay. Our formula only needs the first and the last. So the sum of the 8 terms in this pattern, since there's 8 over 2, the first term is 1 and the last term is 13. So this is 4 times -12, which is -48. Next one here, sum of the first 8 terms, 8 over 2. First term is 5, second term is 66. So we have 4 times, I jumped ahead, didn't I? I was thinking out loud. 61. So 5 plus 61 is 66. And this is 264. All right. Now, when we're doing these series, when we're doing these sums, it's nice to have a shortcut for explaining it. Instead of using all the words or instead of writing out all those numbers, mathematicians came up with a shortcut, and it's this letter right here. This is a Greek letter from the Greek alphabet, and it's the Greek letter sigma, which in Greek is their S sound. Now there's actually two different sigmas, just the same way that we have two different A's, right? We have capital letter A and small case a. So this is their capital letter sigma, and then they have a small case sigma. They both stand for the S sound. And since we're talking about sums, we decided to use the Greek letter S since it goes with sums or series here. So whenever you see sigma, it means sum up the numbers. When you have sigma, you're always going to have a starting and an ending number, and then this is going to tell you how to get the terms in your pattern. So what this is equivalent to is this is equivalent to saying 2 times n plus 3, and you start with the starting number 1. So 2 times 1 is 2, 2 plus 3 is 5. That is your very first term. Next, you're going to say big plus sign here. Next, you're going to say 2 times n plus 3, and you move up to 2. So 2 times 2 is 4, 4 plus 3 is 7. That is your a sub 2 term. Plus sign again. 2 times n plus 3, and this time you put in a 3. 2 times 3 is 6, 6 plus 3 is 9. This is your third term. And because this was your ending number 3, you're done. That's it. And so you would add all of these up. 5 plus 7 is 12. 12 plus 9 is 21. Now, even though that's what's happening, okay, when you see a summation notation like this, thought bubble, most people don't write out all that work. Instead, what they do is they think inside their head, plug in a 1. 2 times 1 is 2 plus 3, and they just write 5. They say plug in a 2. So 4 plus 3, and they write 7, and they write 9, and then they add it up. So down here, we're going to do just this blue part, even though this is what we're thinking inside of our head. So let's try this one. We're going to start with 1, and we're going to end with 6. So plug in a 1. 1 plus 4 is 5. Then go to 2. 2 plus 4 is 6. 3. 3 plus 4 is 7. 4. 4 plus 4 is 8. 5. 5 plus 4 is 9. And then 6. 6 plus 4 is 10, and that's where we stop because that's our last term here. Again, this would be your first term, your second term, your third, your fourth, your fifth, and your sixth. Summing them, again, sigma guy here, means put all your plus signs between them like we already have and add them up. I'm going to go ahead and use our shortcut to help us here. So 5 and 10 is 15, and we have 3 pairs, so 3 times 15 is 45. Now, your sigma does not always have to start with 1. Take a look at this one. It starts with a different number. That's okay. So we're going to start with 5 and end with 7. So in our pattern here, plug in a 5. 5 minus 7 is negative 2. Plus 6. 6 minus 7 is negative 1. 7 minus 7 is 0. And that's where we stop because that is your final number here. And this would be your a sub 1, this would be your a sub 2, and this would be your a sub 3. The sum is negative 3.